Good day. This is my presentation or my video for Deliverable 9. And this is my system, which is Zero Knowledge Biometric Password Manager. And basically, just to start off, an introduction, my name is Kaide Daniel Akilo. And zero knowledge proofs. So zero knowledge proofs, or ZKPs, are a way of proving you know something without actually revealing the secret itself. So for example, I can provide or prove that I know a password, but I never have to send the password across the internet. My project is a zero knowledge password manager, and it combines three main ideas: zero knowledge authentication, so the server never learns your password; biometric security using fingerprint and face recognition; and Shamir secret sharing, which lets you recover your account securely and allows for distributed sharing as well. In simple terms, it's a password manager that protects your secrets even if the server is hacked. Moving on to why zero knowledge proof. Zero knowledge proof, basically today we live in a world where billions of passwords are exposed, and there are a lot of growing digital threats day by day. Traditional password managers often keep a copy of your data, or they rely on servers, which can become a single point of failure. My project is different, as in it never exposes the password or biometric data to the server. And by combining biometrics with zero knowledge proofs, it ensures authentication that is both strong and private. And this means that anytime, even if the server is hacked, the attacker learns nothing about a user's credential. Moving on to the problem statement. Like I've mentioned, password breaches are on the rise, and cyber criminals exploit stolen data to gain unauthorized access into systems and data. Existing password managers often rely on server-side encryption, mostly because it's reliable and obviously very widely used, but it does lead to a single point of attacks as well. Biometric authentication is widely available on devices, but in research, there's not been any integration with strong cryptographic systems like zero knowledge proofs and biometric authentication together. And account recovery remains a major weakness in a lot of systems. The core problem we are trying to solve is how can we create a password management system that maintains zero-side knowledge while providing secure and robust biometric authentication and recovery mechanisms. A little bit on the literature review and related works. In traditional password systems are often vulnerable to brute force and other attacks such as social engineering. Users reuse passwords across platforms, which can lead to easy breaches and easy access to data, and there are predictable patterns as well. Biometric authentication, most systems use unimodal systems, which are limited by single point failures, and multimodal systems improve accuracy but need a better infrastructure and a better system and knowledge in implementing such systems. WebAuthn is a protocol that is also, a secure web-based biometric authentication. Multi-factor authentication, this is the best type of authentication that there is, and it reduces unauthorized access and as well as breaches. And zero knowledge proof, which I explained, enables secure authentication without credential transmissions. The research gaps in this are biometric and zero knowledge integration. There have been limited implementations in both of these tools together. Distributed recovery. Shamir secret sharing is mostly used in bigger projects, whereas this is some of a small project is a bit taboo to use Shamir secret without a big infrastructure. And missing unified framework, combining something that you know, something that you have, and something that you are in ZK systems. And this is what I've done, including something that you know, which is your password, something that you have, which is your device, like your laptop, and something that you are, as in your biometrics, fingerprint, face recognition. And how we've solved these problems is implementing biometric integration, as well as zero knowledge password management, as well as Shamir secret sharing recovery with zero knowledge principles. And what we've done ultimately is accomplish client-side encryption over server-side encryption. The system architecture goes as client-side encryption for the user's password into, and then we then create a zero knowledge proof, and that serves as the server validation. Then for biometric authentication, it then stores the biometric. The database never sees the biometric authentication, but provides secure storage and encrypted vaults. And Shamir recovery is brought from distributed shares upon registration, which I will demonstrate in the demo. Technology implementation. So basically, in our front end, we use Next.js 14, which is used with TypeScript and just allows for our UI to be clean. Backend, we're using Next.js API routes with MongoDB as our database. Cryptography, we're using web crypto and advanced encryption security tools like AES and SHA. Hashing. And then authentication, we're using biometrics and face recognition, such as we're using Face API for it and JWT for session management. Recovery, we're using Shamir's secret sharing, which I've mentioned, and it has a total of 5 shares that can be distributed to other people and include 3 threshold shares as well. The 3 core implementation pipelines are zero knowledge authentication systems, where we use our password-based key encryption with 100,000 iterations with SHA-256. Key generation, so we basically generate the key from client side and never send it to the server. We have our challenge to response, which basically the zero knowledge proof generation for server validation, and obviously session management as well. We also have account lockout as well after 5 failed attempts. Second pipeline is biometric integration, which is just platform authenticator credential creation. And basically we have authentication as well from both AP face recognition and as well as fingerprint authentication. And then obviously no biometric data is transmitted into the database. And then the distributed recovery using Shamir's secret. Basically, we generate shares upon registration, which is 5, and the threshold is 3. And we encode this, and we also add checksum validations so that we know that the keys are not tampered with. And then distributed strategy, encrypted shares distributed to the user, which they can then distribute to anyone that they would like to. And then share integration as well. Cryptographic security matrix. So basically we're using algorithms such as AES, SHA, PBK DF2 with key derivation as well. We also have a method for random generation as well, and hash functions for integrity verifications as well. Performance benchmarks, these are just little stats. While I was doing my test, authentication speed is below 5 seconds for biometrics, 3 for password. Memory efficiency, as we're using MongoDB, we can store up to as much entries in the vault as possible. And then recovery success as well, you just need 3 out of the 5 shares that are given to you upon registration. And this is just the same thing as how for everything that I've spoken about with the PBK and the key variation as well, and as well as Shamir's secret with the 5 total shares and checksum for validation. And basically that then brings us to the results. With all these things that we've researched and all these things that we've built, these are the results. We've managed to then do a zero knowledge architecture, which basically we can confirm that no plain text password is stored or transmitted. Everything is client-side encrypted, and our database then validates it using the proof and the challenge, and then that's how a user is able to go into the system. Biometric integration success. We've managed to implement fingerprint and facial recognition, and users can pick which method they would like to go with. And the reason why I went for 2 separate things is because some devices may have fingerprints, such as mine, while others may only have a webcam, which you can do as a facial recognition as well. And recovery system validation is just reconstruction from mathematically verifiable code, which I will show, and as well as activity logs to capture any recovery attempts as well. The critique and limitations for this. So this is basically browser and device compatibility. So obviously, if your device doesn't have fingerprint, you're not going to be able to log in or sign or register with a fingerprint. Biometric accuracy and spoofing. So biometric accuracy depends on, let's say you use your facial recognition. If the lighting behind you is bad or something's covering your face, obviously the biometric accuracy will be low. And Shamir's secret, it's not complicated, but it's also something that a user needs to think about when registering as well. Then future work, basically just quickly, is just to optimize performance, performance in client-side encryption. Obviously, it is running fast, but it could be optimized. We can extend into mobile biometrics and making this project into a mobile app, and then we can explore quantum resistant algorithms, which have been on the rise lately in terms of how breaches and hacking has been done onto quantum related systems, and as well as conduct penetration testing, which is something that was not done, and just see how we can further test the security. And in conclusion, we've achieved zero knowledge proofs, biometrics, Shamir recovery, and no server ever sees plaintext password, plaintext keys for Shamir or anything like that. And this then leads for the groundwork and the foundation for maybe a next-gen password manager as well. Moving over swiftly to our actual implementation. This is the code. I mean, this is not the code, but this is the demo. And basically what you'll be brought into the zero knowledge password manager, and you can get started, you can log in. Get started takes you to the registration page. Login takes you into the login page. What I'm gonna do is I'm gonna do a registration, and we're gonna do temp mail. And basically we are then gonna copy this and then use that. Password, we're gonna go just a simple one. And then we're gonna register. Once you've registered, it's then gonna take you to this page for recovery shares, and basically we can save these shares, or we can send it to a password manager. So basically we can send it to someone else as well. So I'm gonna send it to myself just so you can see that it does work. And then it's gonna then send it to this email that you've then gonna send it to this email. But just so for time's sake, I'm just gonna copy this just to show you that it actually works. What I'm gonna do is I'm gonna go to my Gmail, and basically I'm gonna change it here, and you can see that it does send you the share value encrypted as well. And cool. So basically then what we then gonna do is we're gonna go back, and you can then continue on with your setup. And then after you've done all your shares and everything, you're gonna be led into the biometric authentication, where you can set up biometrics, you can register, you can log in, or you can actually skip and not do this as well. For what we're gonna do is we're gonna set up biometrics. So you can either do fingerprint or facial recognition. I'm gonna go with facial recognition, and basically I'm gonna allow for it to come here. You have to just make sure that the lighting is good. I just need to position my face in the camera and capture the face. And then once your face is captured, you can then register in biometrics as well. You can also use fingerprint as an option as well, but I want to show you the facial recognition. Coming into the activity log. So once you've been registered fully or you logged in fully, you can go into activity logs or password vault, and basically you can then go to activity logs, and you can see, oh, we successfully registered at this time and it was a success. Same with login, because you logged in and registered at the same time. This is when you start your registration process. This is when you actually logged into the system, and now we've also registered that you used ZKP secured face as well. And then this is another feature that I implemented, which is just password vaults. So basically what you're gonna do is you're gonna come here and you can add a new password, and basically this is also a double up into a password management system, and that's why it's called a zero knowledge password manager, and you can manage passwords in it. And what I wanted to do with this system is you can come in here. So let's say you had your GitHub account, you can store for your GitHub website. You can come in here and say, okay, GitHub, this is my password for GitHub, and you can also auto generate a password, and you can put a master password so that no one can actually see this password. So it's a password management system, and then you can save the password. And then the reason why I brought that up is because the password that my master password is GitHub, so obviously that's not secure. But anyways, that's just for time's sake. And basically we can either view, edit, or delete. So we can view a password, but we need to then put our master password that we made for this specific website, and we can decrypt the password, and we can see that, hey, this is our password for our GitHub account. And you can see it starts with a bracket TT. So just remember that. So now we want to edit it. We can generate a new password, and then we can say GitHub, as GitHub was our password. So basically we can then edit it, and then we're gonna view again to see if it's been changed, and we can decrypt and we can show, and you can see our old password started with bracket TT. Now it's changed. So that's how it works. And then you can also delete it from your vault as well. So basically that's how the password vault works. And in our activity logs, it actually logs everything that we've done. So the password created, the password updated at this time, and the deleted password entry for our website GitHub. So that's basically everything to do here. And you can also log out as well. And then you can also do the recovery account. So basically if you lose your password, you can come in and you can then try to recover your password, and you just put in the account that you want to try to recover, and you have to paste in your shares. Remember when I said you need 3 out of 5 shares to recover your account? Cool. So basically we can then recover our password, and hopefully all these shares are correct. Then we can recover our password, and our password is then recovered successfully. And that's basically how Shamir secret works. Basically we can then get our password, we can go back to login, we can then put in the password that we just copied, put in the email which we just logged in with, and we can actually log in with password, and you can see here we've logged in successfully. So now I've showed you how the biometrics work, how the registration works, the ZKPs, the password vaults, and the activity logs as well, and as well as logout. Now I'm gonna take you through the code as well. So now basically, just to show you how it works, basically we have our ZKP, and basically we have our API route. So this API route is very useful in terms of these is all the operations that we do for our back end in terms of getting and sending requests and getting it from the database. For time's sake, obviously I'm just gonna go into one, which would be this is a longer one, but I don't mind doing a longer one. I just want to show you something very short and easy. So basically, let's go attempts. Actually, let's go. Okay, it's fine. We can go biometric login. Okay, cool. So basically, how the routes work is that we define our functions for post, and then what we want the email. What we want to put and request for is the email and the user ID. Now, if this doesn't exist, and if we haven't put it in, then obviously the email and user ID is required. And then we then connect to the database. And if we have a successful biometric login, it gets stored onto this collection, which is our table for activity logs and user logged in with biometrics, which is what we saw in our project as well. And as well as we generate a token for the user, which from our JWT, which is what I'm going to show you as well. and then we then send a response if the biometrics has failed or if it's true. So this is basically in a nutshell how all these routes work. If we come into recovery, you can see what we want to put this into the database once a user has registered and we want the Shamir secrets. We then provide and insert the recovery attempts for each user, and then obviously login recovery, and they send a 500 or 400 if everything is okay. And then basically that's basically how this API works. This is what I actually want to show you. So I'm going to show you two things. One that I implemented myself, and the other one which was used by an API. So face recognition is what was used by an API, which we used Face API for. So we have our interfaces for face match result and our face data, and this is everything that we actually input into the database. For our facial recognition, basically what we want to do is we get the device information, and basically we then initialize the Face API on the actual browser. And how we get these models for our face recognition is over here in the models. So we imported this from our Face API, and we have all these different stuff. So we have for face landmark, which which basically for all the eyes, all the nose, and all the mouth recognition in the face. So we have face recognition as well. Obviously, they're not meant to be looked at like this, but that's basically how we then input. That's basically how we then get the importation of these recognitions. So basically we use Face API, and here we're using our tiny face detector, which detects our faces. We then use face landmark, which like I said, it detects all the eyes and the mouth. Face recognition.net, and as well as face expression, which basically recognizes emotions on the face. And basically we import all this onto the browser, and then we load it, and then we initialize it. And if it's true, the face recognition models are loaded, and if not, then it's not been recognized. Then we basically then check if the user has face recognition compatibility as well. And then we then capture the face from the camera using our HTML visual element, which is our DOM element. And then we then use the detections for all the faces on the screen. And then if there are no faces detected, then no face is detected on the image. If there's multiple, then we only need one face to be detected. Then we send them an error. And then basically we then calculate the quality of the face, and then using the face descriptor base, and I'll calculate quality, and then we then return this onto the database using our routes as well. We then calculate the face quality, which basically does our confidence. So depending on the score, by default is 50. If the quality is over 0.9, then we add 30. If it's over 0.8, then it's 20, then 7. We also detect the face size factor. So basically, if your face is closer to the screen, you get 20 plus in quality. In terms of if it's further away, it will be less than 5, and it's more than 5,000, then you get a plus 10 quality. And same goes with the facial expression. And what this does is just this contributes to the quality of the face recognition. And then the face descriptor to base 64. So basically, the Face API returns a float 32 array, and basically we have to then change it into a unit 8 array, and then in the latter we have to change this binary value for our int for each for our base string. We then have to change this into a base 64 that can then be saved onto the database. So initially, float, the descriptor is a float 32 array and a buffer which cannot be sent onto the database. So then we have to convert the unit int 8 array into a base 64 for it to be transmitted properly. This method does the reverse of what I just said. And then we generate fallback data basically just getting the timestamp, the device info as well. Then we then generate an ID for the face, and then this is where we then match the two faces once they log in and when they register. So we calculate the string similarity, and then if it's over 0.8, then it's a match. And basically we then calculate the Euclidean distance. So basically it converts the distance to a similarity score. So the lower the distance, the higher the similarity. And then we have a 60% threshold for face recognition. If it's above 60%, then your face recognition is valid. If it's below, then that means you do not look like that person. And then we then calculate the string, and then we then generate a ZKP proof, and then we validate the ZKP proof. And then this is basically for capturing the face of the user using our DOM elements and accessing the webcam on a user's device. And this then stops the device. Speaking about ZKP, since this is the bulk of our, since it's the basis of our project, I'm just gonna go through it quickly before I go into the ones that actually implemented from scratch. So basically for our ZKP, we generate, in our crypto actually, we get a derived key. So we use an AESM, which is our advanced encryption system, and basically we encrypting our AES. So anytime we get a password, basically what we're gonna do is first we're gonna take our text encoder, which then turns this into bytes, turns the password into bytes. We then get our random values, and then we then use our crypto to then get an initialization vector, and use our algorithm and encode the plain text, which will be our password. Then we then turn this into a base 64 string so it can then be sent onto the database. And then this is just the opposite, where we decrypt it. So anytime a user logs in, we get the password from the database, and basically here we then changing from a byte into from a base 64 into a byte, and then decoding that text to see the plain text password. And this is basically an array buffer, and this allows to change buffers into base 64. And basically what the buffers cannot be sent onto the database. So in terms of encrypting and using crypto and encoding, basically the value that we get is an array buffer, which cannot be sent onto the database. So we have to then change it to a base 64. And then, so basically this is what these functions do. Then we then export the key variation, and then we derive the key for raw password buffer. And then we then encrypt this with using our PBKDF2 encryption. We sorting this with 100,000 iterations. So basically this then minimizes brute force attacks. We then encrypt and decrypt, and then this is our fallback using XOR. So this is just a fallback that I added, so just in case these functions don't work on a device. And then we can use XOR, which then just compares the login password with the registered password as well. And then one thing I actually want to show you, which will be the last thing, is basically something that I made from scratch, which is basically the SMTP. So how you saw me send my Shamir to a user, to myself, is basically I make a STMP client, I'll host our port, and then username and password, and then basically the constructor as well. We then initialize these, and then our port is 465, which is basically a secure port for transmissions. Then we then make an async. Basically, we then transporting this. So this function is for sending of the email, and then we then use 465, and then we then using our auth, which is our user and a password name. And then basically what we then do is we then verify the connection, and then send the email to the user. Our mail options are our subject, our body, and our share value. And then basically these are just if everything is good, then it sends successfully. If not, then we send an error email as well. And the rest of the code is basically just code in terms of MongoDB and our databases. We have pages where we then create our front end. So this is basically using Tailwind TSS to just create our front end, which is basically what you see for our UI, and everything is then incorporated with everything. Our Shamir secret, this is also something that doesn't use libraries as well. We generate a random string, we hash it to convert the hash into a 32-bit integer. We use XORs for the share values as well, and then we then reconstruct the secret from shares anytime we get it to reconstruct passwords as well. And overall, this is basically how the Shamir secret works. Apologies for speeding. I just see that it's past like 30 minutes now, so I don't want to spend time on it. But we then reconstruct the secrets that we send, and then we store it, and then we then validate the shared hash with the inputted hash that the user is given to recover their system. And that in a nutshell is how Shamir works. And this was done without somewhat any libraries. And yeah, so the only thing so I showed you the fingerprint, which uses the libraries, and the face recognition, which uses libraries, and something such as the SMTP, which I built from scratch. And yes, so this is everything to do with my project. Sorry that the video is super long, but yes, so this is everything. I hope you have a good day, and yeah, thank you.